Let's see the next problem, sir. Profit maximization. Profit maximization. This is example number 37. CMA material. What is the question? Solve the following transportation problem for maximum profit. It is given in the question. You have to solve the given problem to maximize the profit. Okay. There are 3 warehouses XYZ and 4 markets ABCD. 180, 320, 100, 400. Let's check up, sir. 200 plus 500, 7, 3000. Availability is 1000. Requirement 180 plus 320 plus 100 plus 400. 1000. It is a balanced transportation problem. It is a balanced transportation problem. So what I am doing here, sir? I am converting the profit matrix into an opportunity loss matrix. How can I get this one? Identify the maximum profit in the given table. 25 rupees is the maximum profit. Subtract each and every element. From 25 to convert profit matrix into an opportunity loss matrix and treat it as a cost matrix. So 3 warehouses, 4 markets, requirement, availability. 25 minus 12, 13. 25 minus 18, 7. 25 minus 6, 19. 25 minus 25, 0. 25 minus 8, 17. 25 minus 7, 18. 25 minus 10, 15. 25 minus 18, 7. 25 minus 14, 11. 25 minus 3, 22. 25 minus 11, 14. 25 minus 12, 20. This is 15. Sorry, 5. 25 minus 25. This way, a profit matrix is first converted into an opportunity loss matrix, which is called cost matrix also. 180, 320, 100, 400. This is 200, 500, 800. This is 300. 300. Let's calculate initial solution by Ogle's approximation method. P1, lowest 11, second lowest 2, difference is 2, 7 and 18 means 11, 14 and 15 means 1, 0 and 5. Column wise penalties are calculated. Let's go for row wise penalties. 0 and 7 means 7 rupees. 7 and 15, 8 rupees. 5 and 11, 6 rupees. 5 and 11, 6 rupees. What is the maximum penalty? 11 rupees. Maximum penalty is 11 rupees. Corresponding to this 11, least value is 7. Least value is 7. How many units are required? 320. But how many are available? 200. 200 I am supplying. Requirement is reduced to 120. But availability is over. So this warehouse is eliminated from the picture. This warehouse is eliminated from the picture. Calculate penalties 2. 11 and 17, 8. 18 and 22, 4. 14 and 15, 4. 5 and 7, 2. Row wise also calculate penalty. Dash. 7 and 15, 8. 5 and 11, 6. 8 is the maximum penalty at 2 places. 8 is the maximum penalty and it is at 2 places. Corresponding to the site, least 11 rupees. Corresponding to the site, least cost is 7. So preference is given to the site. Corresponding to this, 400 is the requirement, 500 is the availability. 400 units are given. So requirement is, availability is reduced to 100. Requirement is fully satisfied. Requirement is fully satisfied. This column also eliminated from the picture. Penalty 3. 11 minus 17 means 6. 18 minus 22 means 4. 14 minus 15. This is 3. Dash. Let's go penalty 3. Dash. It is 15 and 17, 2. This is 11 and 14, 3. 11 and 14, 3. So maximum penalty is 6. Corresponding to this maximum penalty, 11 rupees is the least cost. 180 requirement given, 0. It is 120. This market requirement is satisfied, it is eliminated. P4 dash. 18 and 22, 14, 4. 14 and 15, 1 dash. Now sir, P4 dash 15 and 18 means 3, 14 and 22 means 8, maximum penalty is 8, corresponding to this maximum penalty 14 is the lowest, least value, 100 required, 0, 20. This market requirement is also satisfied. Finally, At market B, 120 units are required. 20 plus 100, 120 units are available. Adjust. Without giving any importance to cost. 100, 20, this is 0. These 20 units are given here, 0, 0. Finally, capacities are exhausted, requirements are also satisfied. So the way of allocation is correct. Let's go for the condition. Number of occupied cells required. Number of occupied cells required is equal to m plus n minus 1. How many rows it is having? 3. How many columns it is having? 4 minus 1. 6 occupied cells are required. 6 occupied cells are required. Number of occupied cells obtained. Number of occupied cells obtained is equal to 1, 2, 3, 4, 5, 6. Since number of occupied cells obtained is equal to number of cells required. So it is a basic feasible solution. It is a basic feasible solution. Calculate the transportation cost here. Calculate the transportation cost here. 7 into 200 is equal to memory plus. 18 into 100 is equal to memory plus. 7 into 400 is equal to memory plus. 11 into 180 is equal to memory plus. 22 into 20 is equal to memory plus. 14 into 100 is equal to memory plus. MRC 9820. Transportation cost is okay, it is not written over there. Seven into 200 check up with study material. 18 into 100. 7 into 400. 11 into 180. 22 into 20. 14 into 100. 9820 is the cost. Let's go with the profit, sir. Same cells. Original matrix is the profit matrix. So first one is 18. 18 into 200 is equal to memory plus. Second row, second column. 7 into 100 is equal to memory plus. Next, 18 into 400 is equal to memory plus. 14 into 800 is equal to memory plus. 3 into 20 is equal to memory plus. 11 into 100 is equal to memory plus MRC. This is the value you will get. Okay, let's improve the solution here. That is optimality test we have to perform. Optimality test we have to perform. Here I can calculate total profit. Total profit. Okay. Take the sales values, this one 200, multiply with the corresponding profit. Multiply with the corresponding profit. One more time, 18 into 200 is equal to memory plus. Next, 7 into 100 is equal to memory plus. 18 into 400 is equal to memory plus. 14 into 180 3 into 20, memory plus, finally 11 into 100, 15,180. 15,180, our value is coinciding with the answer given. This is the profit obtained for the given transportation table by Ogle's method. Now we are trying to improve the solution. Before I am going for the optimality test, sir, you take up the solution. I'll give you 2 minutes time. Okay, sir. Look at this one, how this profit is derived. I am considering number of units as it is, but original matrix, profit matrix is calculated, considered. So, profit, per unit profit is taken from the given profit matrix. One more time I am repeating, per unit profit, I am taking from the given profit matrix, number of units supplied from various warehouses to markets taken from the solution. So it is 15,180. If you consider this one, you will get the cost. Anyway you can express. Okay, sir? Now, we have to perform the optimality test, which is obtained here. So step number 2, optimality test. Calculation of UI and VJ for occupied cells. Now consider the cost only. First row, second column 7, second row, second column 18, second row, fourth 7, third row, first column 11, third row, second column 22, third row, third column 14. So 1, 2, 3, 4, 5, 6. 6 occupied cells are required. 6 cells are considered by us. Now you have to place 0. Third row is having maximum occupied cells. Put 0 here. Put 0 here. 14 minus 0, 14. 22 minus 0, 22. 11 minus 0, 11. By placing third row index as 0, sir, 3 column indices are calculated. Now corresponding to this 22, 2 more occupied cells are there. 18 minus 22 is minus 4. 7 minus 22 is minus 15. So column indices are obtained. row indices are obtained, one column index left over. 7 minus of minus 4. 7 minus of minus 4, 11. So, calculation of UI and VJ for occupied cells is over. Step number 3. Calculation of UI plus VJ for empty cells. For empty cells. Calculation of UI and plus VJ for empty cells. Now sir, put an identification mark in the occupied cells. Write UI and VJ values which are obtained here at step number 2. Zero. So 0 plus 11 is 11. Minus 15 plus 11 is equal to minus 4. Minus 14 plus 14 is equal to 0. Minus 15 plus 14 is equal to minus 1. Minus 14 plus 11 is equal to minus 3. Minus 15 plus 11 is equal to minus 4. So let's go for step number 4. Step number 4. Calculation of Dij matrix. This is equal to Cij matrix minus Ui plus Vj for empty cells. Now, let's write the cost. 13 rupees minus 19 rupees minus 0 minus. Next 17 rupees minus 15 rupees minus 5 rupees minus. Cost is taken from this matrix. This is step 1. And UI plus Vj values you have to take. 13 minus of minus 4, 17. 19 minus of minus 120. 0 minus of minus 4 plus 4. 17 minus of minus 3, this is 20. 15 minus 0 is equal to 15. 5 minus 11 is minus 6. 5 minus 11 is minus 6. Except one value, sir. Except one value. All other values are positive. So what I have to do? Once again, a negative value in the Dij matrix I am facing first time. A negative value in the Dij matrix I am facing first time. Then what to do? First let us see what it is indicating. From any of these occupied cells, if I shift one unit to this particular cell where I have a negative value, my cost will decrease. At a rate of 6 rupees per unit. One more time. All these values are positive except last row, last column value. What is that minus 6 interpretation? When you shift one unit from any of these occupied cells, to this negative cell. Negative cell in the sense a cell with a negative value. A cell cannot be negative, sir. A value inside the cell can be a negative. So cost will decrease at a rate of 6 rupees per unit. Since Dij value Dij matrix is having a negative value. Dij matrix is having a negative value. So basic feasible solution BFS is not an optimal solution. BFS is not an optimal solution. So we have to improve. Okay, sir. Again, I am giving 2 minutes time for you to note down these things because I need space, sir, very badly. So take up this. Okay, sir. Now, consider the BFS once again. Consider the BFS once again. Consider BFS once again. Now, sir, this is first row, second column. 7,200. Second row, second column. 18,100. Second row, last column. 7,400. 11,180. 22,20. 1,400. This is my basic feasible solution, which is obtained by Ogle's approximation method. Then come back to this Dij matrix, sir. Dij matrix is having negative value where? In the third row, fourth column. Third row, fourth column. So we have to shift some units, or we are trying to shift some units from one of these occupied cells to this empty cell, because at this stage we don't know from which cell I have to shift the units. And one more thing, how many units I can shift, that is also not known to us. So what I am doing, sir? Placing theta here, plus sign. So this theta will indicate theta number of units, I am shifting from these occupied cells to this empty cell without disturbing the demand and supply condition. What does it mean actually? This is the availability at these three markets, at these three warehouses. 1000 is the total availability, and for these four markets 1000 is the requirement. Excess availability is not there, excess requirement is also not there anywhere. Okay sir? So when I am shifting some units here, I have to take care. What is that point? Without disturbing the demand and supply condition. Look at this. Whoever watching this one first time sir, or whoever doing transportation problems first time, you will get some doubt, confusion, how to shift the units. Okay, every batch I am facing the same problem. Therefore, I am repeating this point one or two times. Put a plus sign here. What is the effect of placing a plus sign here? This row total, you are increasing by theta number of units. By placing theta here and a plus sign means theta number of units I decided to shift here. By doing so, this row total is increased by theta number of units. But sir, there is no excess availability at this warehouse. Simultaneously, this market requirement is also increased by theta number of units. And again, at this market, there is no excess requirement. Clear? Look at this one more time. I am placing theta here and a plus sign is also placed here. By placing a plus sign here means theta number of units you are shifting from one of these occupied cells to this cell. By doing so sir, immediately this row total is increased by theta number of units. This row total is increased by theta number of units. And this warehouse, there is no excess requirement. Only 300 units are available. One more point to notice is, this market requirement also you are increasing by theta number of units. This market requirement you are also increasing by theta number of units. Once again same case, this market does not require any additional units. So internally we have to adjust. How can I adjust sir? Starting from this cell where theta is placed, move horizontally or vertically from one occupied cell to another occupied cell and try to reach the initial place. This is called tracing a closed loop. Look at this, how I am moving. Theta, here plus sign. From this I am moving horizontally. This is 20 minus theta. Immediately minus I am placing here. What is this symbol sir? Speed breaker symbol. This occupied cell is missed by us. If you don't want, you can skip one of these occupied cells, no problem. It is not compulsory that you have to move from one occupied cell to another occupied cell. Anyway, you are moving horizontally. By skipping this occupied cell also, you can reach to this particular cell. And after reaching this cell, I am moving vertically sir. It is 100 plus theta. Again, coming back to this 400 minus theta, reaching to the original place. A closed loop is formed. Look at this point one more time. When I place theta here, this column total is increased by theta number of units. This row total is also increased by theta number of units. So, to neutralize this effect, that is without disturbing the demand and supply conditions, sir, I am moving from one occupied cell to another occupied cell, by placing minus plus minus, starting with plus, alternative minus plus minus. Why this is required? If I have a minus sign here, theta number of units I am subtracting from here, theta number of units I am subtracting from here. So this column total is decreased by or reduced by theta number of units. So I have to neutralize that effect. So in the next occupied cell, a plus sign is placed. When a plus sign is placed here, this row total is increased by theta number of units. This row total is increased by theta number of units. So neutralize this one. In the next occupied cell, a minus sign is placed. From this, I reach to the original spot. This way, a closed loop you have to form. Okay, sir? Look at this, I am writing here. So, from this occupied cell, I started my journey, reach to this cell, from this occupied cell to another occupied cell, from this occupied cell to another occupied cell, again from this occupied cell to the original place. So, start plus, alternative minus, plus minus. This way a closed loop is formed. One more interesting point here a student has to remember is 4 occupied cells are required minimum. Minimum 4 occupied cells are required, sir, whenever I want to form or whenever I want to trace a closed loop. Minimum requirement is 4. As such, there is no condition for maximum. You want, you can use all the occupied cells, no problem. Okay. Now, once a closed loop is formed, how to calculate the theta value? How to calculate the theta value? Look at this, sir. This is theta. This is 22 minus theta. This is 100 plus theta. And this is 400 minus theta. Again reach to the original spot. Again reach to the original spot. Okay, sir. Equate minimum of the negative values, negative corner values are simple. Identify where theta is negative. Theta is negative here in this corner and theta also negative at this corner. Minimum of these two are equated to 0. Theta is equal to minimum of these two. First, in the closed loop, identify where theta is minimum. Identify where theta is minimum. Clear? After that, look at the numerical numbers. Here it is 400, here it is 200. Minimum of these two is equated to 0. So 22 minus theta is equated to 0. This is 20. It is cost. Units I have to take 20. 20 and 400. Minimum is equal to 20. That is equated to 0. Okay, sir. Once again, one more doubt you will get. Why negative values only equated to 0? Why? The values where theta is negative is equated to 0. Why not positive values? Okay, sir. Look at this. 100 plus theta is equated to 0. 100 plus theta, when it is equated to 0, theta is equal to minus 100. Theta is equal to minus 100 you will get. But theta is what, sir? Number of units you want to shift from one occupied cell to another occupied cell. Therefore, number of units cannot be negative. Number of units cannot be negative. Therefore, positive cells. Theta where positive. Theta with positive sign corners are neglected. Theta with positive corners are neglected. Now what left over? Theta with negative sign. Theta with negative sign. Why minimum value only? Why not maximum value? One more doubt, natural sir. Whoever doing first time, you'll face these problems. Why minimum value only? Why not maximum? Okay, I'm giving answer to that question also. Suppose 400 minus theta is equated to 0. 400 minus theta is equated to 0. Theta you will get 400 units. Okay. So these 400 I have to subtract and add here. At these corners 400 is added and subtracted. In the place of theta I will get 400. 20 minus 400 is minus 380. 20 minus 400 is minus 380 sir. Again negative value you are getting. Number of units cannot be negative. Therefore minimum value is equated to 0. Minimum value is equated to 0. So theta is equal to minimum value of negative corner values loop are equated to 0. Negative corners means where theta is negative sir. Don't interpret this in any other way. Where theta is negative, only those values. And out of those also minimum value, they are equated to 0. So this is minimum of 20 minus theta comma 400 minus theta. This is equated to 0. 420. What is the minimum value? 20 is the minimum value. So 20 minus theta is equal to 0. Implies theta is equal to 20 units. Implies theta is equal to 20 units. So you will get first improved BFS. First improved BFS. Here in the first row, second column, neither I have plus sign nor minus sign. So this cell will remain same. It is 7 and 200. Go to the second row, sir. The cell with 18 rupees has cost. You have a plus sign. Means 20 units are added here. Cost will remain same, but number of units are 120. And this is 7 rupees cost. Minus sign is placed here. It means 20 units you have to subtract. 20 units you have to subtract. Here it is theta. Cost is what? Here. Cost is 5 rupees. 5. Theta is 20. Theta is 20. Next, sir. This 1400 will remain same because I don't have any plus sign or minus sign here. This will remain same. This will empty cells are 20 minus 20 0. This 11 and 180 will remain same. 11 and 180 will remain same. Look at the number of occupied cells required. 6. 1, 2, 3, 4, 5, 6. 6 occupied cells as it is we have. Clear? Now, this is not the end of the story, sir, for this problem. This is not the end of the story. Why? We don't know whether it is an optimal solution or not. We don't know whether it is an optimal solution or not. So, we have to perform optimality test for first improved BFS. First improved BFS. Okay. When first improved BFS is up, when I am doing optimality test for first improved BFS, initial solution is not required, which is obtained by Ogle's method. You have to concentrate on first improved BFS. Clear? So till this portion you have noted. So these are the 2 more steps you have to take up. 1 minute time I am giving, sir. Note down this. Then I will go for further calculations. So this one I am writing here so that I can use this space. First improved BFS. Seven 200, 18 120, 11 180, 1400, 5, this is 20, 7 380. 1 2 3 4 5 6. Now look at the solution. Calculation of step number 2. Calculation of UI and VJ for occupied cells. This is 7 rupees, 18 rupees, 7 rupees, 11 rupees, 14 rupees and 5. Okay. Now putting 0 here, 5 minus 0, 5, 14 minus 0, 14, 11 minus 0, 11. Next. 7 minus 5 is 2, 18 minus 2 is 16, 7 minus 16 is minus 9. So a unique set of UI and VJ values are obtained. A unique set of UI and VJ values are obtained. Step number 3. Calculation of UI plus VJ for empty cells. Put an identification mark in the occupied cells. Right here, sir, for better visibility. Step number 3. Calculation of UI plus VJ for empty cells. Now write the UI and VJ values as usual. Now, minus 9 plus 5 is minus 4, 2 plus 14 is 16, minus 9 plus 14 is 5, 0 plus 16 is 16, 2 plus 11 is equal to 13, minus 9 plus 11 is equal to 2. Minus 9 plus 11 is equal to 2. Now, sir, step number 3. Step number 3 over step number 4. Calculation of Dij matrix. This is equal to Cij matrix minus Ui plus Vj for empty cells. For empty cells. Now write the cost from the original matrix. 13 rupees minus 19 rupees minus 0 minus 17 rupees minus 15 rupees minus 22 rupees minus, it is an empty cell now, sir. Okay. Now 13 minus 2, this is 11. 19 minus 5, this is 14. 0 minus of minus 4, this is plus 4. 17 minus 13, this is 4. 15 minus 16, this is minus 1. 22 minus 16, this is 6. One more negative value is obtained. One more negative value is obtained. It means first improved BFS is also not an optimal solution. First improved BFS is also not an optimal solution. Since Dij matrix is having a negative value, comma, first improved BFS is also not an optimal solution. Not an optimal solution. So we have to improve, sir. So then what you have to do now? 1, 2, 3. These are 3 steps you have to take. Note down these 3 steps. 1 minute time. Okay, sir. So I hope every one of you have noted step 2, step 3, step 4. Only this part I am eliminating from the picture. First improved BFS is this one. I have to form a loop one more time. Okay, sir.